Okay, in this video we're going to be finding the gradient of straight lines based on some of the graphs that were shown. So in the first example we have a straight line that is going through the origin, and it is also passing through the point 1, 5, so that would be the point with coordinates 1 and 5. So in order to find the gradient, we need to just calculate the rise over run ratio. So in this case what we can infer is we have this, we're advancing by 1 unit on the horizontal axis, and then we're going up by 5 units on the vertical axis. So that means that the gradient, and normally the gradient is called m in mathematics, is represented by rise over run, and that's going to be equal to rise is 5, run is 1, so therefore the gradient is 5. Now if we actually want to identify the equation that corresponds to this line, we can write y equals to 5x. It's because we know that the coefficient next to x is the gradient m, and then the y-intercept in this case is 0 because it is going through the origin. Now we're going to do the same thing for this one. Now we notice that we're actually going down, so what we can do here is, okay, so if we move to the right, we're moving by 3 units, but then as we move to the right, we're actually moving down by 3 units. So in this case, the gradient is going to be minus 3 because we're moving down, divided by 3, and then that's going to be equal to minus 1. So the equation that corresponds to this line is going to be y equals to minus x. Okay, so the gradient is minus 1. The intercept is once again y equals to 0. And then basically this is the equation that is going to correspond to that line. So that's very, very straightforward, and it's really good just knowing how to derive these things just based on those simple ratios there. Now let's do some more examples. Oh, okay, so this one is a tricky one. And the reason it is a tricky one is because we notice the line here is actually a horizontal line that is parallel to the x-axis. Now, there's no points of reference here because we could select something like, let's say x equals to minus 3. Then the value of y is minus 2. Then we can choose another point here, x equals 0. The value of y is once again minus 2. So the rise is virtually 0. In this case, the gradient is going to be 0 elevation divided by 2. And in this case, actually, yeah. No, actually, there's no run. So in this case, it's just going to be 0. Because we haven't really defined the run. We could define any number that we want. We could say 3 units, 4 units. No matter how you move, the elevation is always 0. So that means that the gradient is 0 itself. So in this case, what we can actually say, okay, so y is going to be equal to 0x, but that's just 0, right? But y is not 0, y is equal to minus 2. So the y-intercept goes in here. And that's why the equation of the line is just y equals to minus 2, because it only has a y-intercept, it has 0 gradient. Now this one is a little bit more tricky because we're given a vertical line, and if you think about it, what is the gradient of a vertical line? I mean, you could select any elevation that you want, but then you're not really moving horizontally. So what should the gradient be in this case? Well, in this case, there are two ways of looking at this. We can either say the gradient is undefined, or we can say that the gradient is infinity. And the reason for that is that we're essentially going up. I mean, we're going up continuously, we're not moving horizontally, so that means that this thing is just going to always go up. Or we could actually look at this from this direction and make x the vertical axis, and in that case what we would actually notice is that this is very, very similar to what we have here. So in that sense, if we were to write an equation of x in terms of y, we would say that m of x in terms of y is going to be equal to 0. Because looking at it in this direction, we would actually see that this line is horizontal or parallel to the y-axis here. So in this case, what we can write is x is going to be equal to 0 times y, so this would be the gradient here. And now the x-intercept is going to be minus 3. And therefore, the equation of the line is x equals to minus 3. So you have to be very careful with questions like this, because they can throw you off by saying, okay, we don't really know what the gradient is. It could be infinity, it could be something like that. But in general, we would say, okay, so let's just express the equation in terms of x and y, so that way we can actually write this properly. Alright, so now the next step here is going to be, we're going to move up to equations that have two intercepts. So how do you find the gradient of that? Well, you do the exact same thing. You choose 2 points on that line, and then you just take the difference. So the gradient is usually one of the points minus the other. So in this case, let's say we take these 2 points here, the two intercepts. So we're going to the right by 1 unit. That's the run. And the rise is going up by 2 units in the same. So basically, we can write this as a gradient of 2. And the equation that corresponds to this line is going to be y equals to 2x. But you notice that in this case, the line does not actually cross the origin, which means that we need to actually add the y-intercept, which is 2. So that's how you would write the equation of the line for this. So generally, you have two parameters, two pieces of information in your equation that tell you exactly what it looks like. The first one is the gradient, so basically m, and the second piece of information, which sometimes we call b or c, or it's just any constant, is the y-intercept. And we're going to go back to this gradient-intercept form a little bit later on. But this is how you derive the equation of a line based on its graph on the Cartesian plane. And now for this last one, let's see what we have. So in this case, we're going to the right by 1.5 units, but we're going down by minus 2 units. So that means that the gradient is going to be minus 2 divided by 1 divided by 2. So what is this going to be? Well, this is a simple division of fractions. We can write it like this. Minus 2 divided by half. And we know from our fraction skills, so our skills with dealing with fractions and rational numbers, that we can rewrite this as minus 2 times 2 over 1. So we're just going to flip this over. And that's going to become minus 4. So that means that for this line, we're going to have the equation y equals to minus 4x. And then we need to add to that the y-intercept. So in this case, the intercept is also at 2. So we're just going to add a 2 to that. And that's going to be our equation of the line for that. And we can always check that by simply plugging in the values that were given here. So if, for example, we plug in the value of x of half, then this becomes minus 4 times half is minus 2, and then plus 2 is 0, and then y is 0 at that point, so that's correct. And we can do the same for plugging y equals to 2 or x equals to 0, and we find that that is actually the case. And basically, that's how you find gradients and equations of the lines based on the graphs of those lines.